KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Okay. My next question, question number 8. The area between y square equal to x and the line x equal to 4 is divided into two equal parts by the line x is equal to a. Find the value of a. Okay. Now y square is equal to x. This is the parabola y square is equal to x symmetrical about x axis. Y square equal to x symmetrical about x axis. Okay. Now line x is equal to 4 given. This is x equal to 4 line. Now this is the shaded region area. My rough line, a line x is equal to a given, which is dividing this entire region in two equal parts. We have to find the value of a. Okay. But don't think that x is equal to 2 will divide this part in two equal areas, because this is x equal to 2, x is equal to 4. Okay. Because now here towards origin, here area is less. Now as you move away from origin, area will be more. Okay. So x is equal to 2 is not the correct answer. Now we have to find x is equal to a. What is value of a? So that area of this region and area of this region both are equal. Okay. A given question is area between the parabola and the line. What is the parabola? Y square is equal to x parabola, and the line x is equal to 4 divided into two equal parts by the line x is equal to a. Okay. So we have to find the value of a. Okay. Now this is the parabola y square is equal to x. Okay, symmetrical about x axis, and line is what? X is equal to 4 line. Okay, now this entire region area, now x is equal to a line. This is now what is given? This area is equal to this area. So nothing but here only one first quadrant area if you check, area of OAD, this area is equal to area of CD AB. Okay. This is given. So it is nothing but what you can conclude is now area of OAD, okay, this area is equal to area of ABCD, okay, this area of OAD, this area is equal to area of ABCD area, this area. Okay. Now if you observe this area both are equal, means area of ODE area of OAE area both are equal. Okay. Similarly, area of CDEF area of ABEF area both are equal. So instead of checking this OAD area is equal to ABCD area, what I will do is area of OED area is equal to area of EFCD area. Okay, that is what I will do. Okay. Now area of OED area. Now this is nothing but y square is equal to x curve between the limits x is equal to 0 to x is equal to a. This area is equal to, now this is the curve is same, y square is equal to x between the limits x is equal to a to x is equal to 4. Okay. So area of ODE, this area is equal to, what is the curve here? Y square is equal to x, limits are x is equal to 0 to x is equal to a. This area is equal to, again curve is same, y square is equal to x between the limits x is equal to a to x is equal to 4. This area, both of these areas are equal. By equating these two, we will get value of a. Okay. Now here in ODE area, curve is what? Y square is equal to x, y is nothing but square root of x. Limits are 0 to a. So area OED is equal to integral 0 to a y dx, nothing but integral 0 to a square root of x dx. This area is equal to, now here limit from a to 4, okay, lower limit is a, upper limit is 4, y dx, y is nothing but square root of x dx, okay. Now here root x integration is what? X power 3 by 2 upon 3 by 2, lower limit is 0, upper limit is a, okay. So here also same thing, square root of x integration is x power 3 by 2 upon 3 by 2, lower limit is a, upper limit is 4, okay. Now here by substituting in place of x upper limit minus lower limit, what we get, this 3 by 2 in denominator comes in numerator as 2 by 3, 2 by 3 into, by substituting upper limit a here, so what will get, a power 3 by 2 minus 0 upon 3 by 2, 3 by 2 in denominator comes in numerator as 2 by 3, so 2 by 3 into a power 3 by 2 minus 0 is equal to, right hand side this 3 by 2 in denominator comes in numerator as 2 by 3, 2 by 3 into, in place of x if you substitute 4 power 3 by 2 minus a power 3 by 2, okay. But 2 by 3 get cancelled on both sides, so a power 3 by 2 is equal to 4 power 3 by 2 minus a power 3 by 2. Now minus a power 3 by 2 comes to this side, plus a power 3 by 2, already a power 3 by 2 is there, a power 3 by 2 plus a power 3 by 2 is 2 times of a power 3 by 2 is equal to 4 power 3 by 2. 4 power 3 by 2 is nothing but 2 power 2 whole power 3 by 2, 2 get cancelled, 2 cube is nothing but 8. So both sides 2 cancel, a power 3 by 2 is equal to 4, a is equal to what? 4 power 2 by 3. Therefore the value of a is how much? 4 power 2 by 3, okay. Now here given question is find area between the parabola y square is equal to x and the line x is equal to 4, okay. This area is divided into two equal parts by the line x is equal to a. We have to find the value of a, okay. So y square is equal to x, parabola symmetrical about x axis passing through origin, okay. Now x is equal to 4, this is the line. Now one arbitrary line x is equal to a dividing these two areas in two equal parts. So what we can write, this area AOD area is equal to area of ABCD. It is nothing but area of ODE nothing but is equal to area of CDEF, okay. Now area of ODE, this area is nothing but what it is, lower limit is 0 to upper limit is a, okay, y dx. What is y? Y is square root of x dx, okay. So this is area of curve OED, okay. Now CDEF area, nothing but lower limit is a, upper limit is 4, okay, y is nothing but square root of x. So area of CDEF is equal to integral a to 4 square root of x dx, okay. Now here root x integration is what? X power 3 by 2 upon 3 by 2, lower limit is 0, upper limit is a. Now this 3 by 2 in denominator comes in numerator as 2 by 3, 2 by 3 x power 3 by 2, lower limit is 0, upper limit is a. By substituting upper limit, what will get 2 by 3 into a power 3 by 2 minus 0, nothing but 2 by 3 into a power 3 by 2. Anyhow here right hand side x power 3 by 2 upon 3 by 2, lower limit is a, upper limit is 4, this 3 by 2 in denominator comes in numerator as 2 by 3, okay. By applying upper limit, 4 power 3 by 2 minus a power 3 by 2, okay. 2 by 3 get cancelled, okay. So what we have, a power 3 by 2 is equal to 4 power 3 by 2 minus a power 3 by 2. Write this term this side, 2 times of a power 3 by 2 is equal to 8, 2 cancel on both sides, a power 3 by 2 is equal to 4, a is equal to 4 power 2 by 3. That is the value of a. Value of a is 4 power 2 by 3. Next, applications of integration, we are continuing exercise 8.1. 9th question, find the area of the region bounded by the parabola y is equal to x square and y is equal to mod x, okay. First of all, y is equal to x square, it is a parabola symmetrical about y axis, okay, parabola symmetric about y axis, okay. Now y is equal to mod x, this is also symmetrical about y axis, both passes through origin, okay. Now this is the parabola, y is equal to x square parabola, and y is equal to mod x, y is equal to x when x is positive, y is equal to mod x is y is equal to minus x when x is negative. Okay. Now these are the curves. Both are symmetrical about y axis, both passes through origin. Okay. Now if you observe, this is y is equal to x line, this is y is equal to x square, positive side of x. Okay, y is equal to minus x when x is negative, y is equal to x square. Now if you observe, this area both are same. So instead of calculating entire area, what we will do is we will calculate in first quadrant area, multiply with 2. Required area is equal to 2 times of area of shaded region in first quadrant. Okay. Now first of all, where these two curves are intersecting, so in first quadrant if you consider y is equal to x square and y is equal to x, no, in first quadrant y is equal to x square, y is equal to x. Now by taking point of intersection, what we get, x square is equal to x square is equal to x means x square minus x equal to 0. So x common, x into x minus 1 is equal to 0. So x is equal to 0 and x is equal to 1. So both intersect at 0 0 and 1 comma 1. Okay, both the curves intersect in first quadrant. I am telling, in first quadrant both are intersecting at 0 0 and 1 comma 1. Now one more point of intersection is here, that is minus 1 comma 1. Actually if you consider, this is the curve y is equal to x square, here y is equal to minus x. So x square is equal to minus x square plus x equal to 0, x into x plus 1 equal to 0. So x equal to 0 and x is equal to minus 1. So actually these two intersect at 0 0, 1 comma 1, minus 1 comma 1. Okay, these are the point of intersections. Okay, so what we have to find is, actually we have to find this entire area, this shaded region area, this shaded region area we have to find. Okay, what we have to find. Okay, so here given area is symmetrical about y axis. So first quadrant area, second quadrant area both are equal. So required area is equal to 2 times of area of shaded region in first quadrant. So first quadrant area is nothing but AOCO area, this area. Okay, second quadrant area is nothing but ODBO area. Okay, both are equal. So required area, what we can write, 2 times of area of shaded region in first quadrant. Okay, now here to calculate this area, this shaded region area, what we will do is we will calculate, observe carefully, upper curve area minus lower curve area, upper curve area minus lower curve area. Now what we are calculating from limits 0 to 1, okay, 0 to 1 we are calculating. Now if you observe 0 to 1, y is equal to x is upper curve, y is equal to x square is lower curve. Between 0 to 1, y is equal to x is upper curve, y is equal to x square is lower curve. Okay, now if you calculate 0 to 1, y is equal to x, y is equal to x, what we get exactly is we will get area of the triangle OAM. This triangle area will get. Okay, triangle OAM area will get 0 to 1, y is equal to x area is nothing but triangle OAM area. Okay, next, what is lower curve? Lower curve is y is equal to x square. Okay, 0 to 1, 0 to 1 y is equal to x square area, nothing but 0 to 1, 0 to 1 y is equal to x square area is nothing but area bounded by OCAM, this area will get. So upper curve area minus lower curve area gives this shaded region area. Okay, upper curve area minus lower curve area gives required shaded region area. So required area is equal to 2 times of area of shaded region in first quadrant only. Okay, so 2 times of integral 0 to 1 y2 minus y1 dx. What is y2 is upper curve, what is y1 is lower curve. Okay, upper curve area minus lower curve area. Okay, now what is upper curve? 0 to 1, y is equal to x is upper curve. Okay, y is equal to x square is lower curve. So 2 times of integral 0 to 1 x minus x square dx. Okay, so 2 into x integration is what? X square by 2 minus x square integration is x cube by 3. Lower limit is 0, upper limit is 1. Okay, by substituting upper limit in place of x 1, so 2 into 1 by 2 minus 1 by 3. 1 by 2 minus 1 by 3. If you take LCM, anyhow if you substitute 0, that is 0 only, no? So 2 into 1 by 2 minus 1 by 3, LCM is 6, 3 minus 2, 1. So 2 into 1 by 6, nothing but 1 by 3 square units. Okay, now here question is to find area of the region bounded by the parabola and y is equal to mod x. Parabola is what? Y is equal to x square, and this modulus function is y is equal to mod x. Okay, given parabola is y is equal to x square, which is symmetrical about y axis and passing through origin, and the curve y is equal to mod x is also symmetrical about y axis and passing through origin. Okay, now first of all, where these two curves are intersecting. So when, if you consider in first quadrant, okay, first quadrant y is equal to mod x is nothing but y is equal to x. Okay, y is equal to x and y is equal to x square. If we equate these two, x square equal to x, so x is equal to 0 and x is equal to 1. So they are intersecting at 0, 0 and 1, 1. Okay, in second quadrant, mod x is y is equal to minus x and y is equal to x square. If you take these two point of intersection, x square is equal to minus x, so x square plus x is equal to 0, x is equal to 0 and x is equal to minus 1. So these two curves are intersecting at 0, 0, 1, 1, minus 1, comma 1. Okay, these are the point of intersection. In first quadrant, 0, 0 and 1, comma 1. So here given area is symmetrical about y axis, means whatever area you have in first quadrant, same area in quantity wise in second quadrant. So area of OA CO area is equal to area of OD BO area. So required shaded region area is equal to 2 times of area of shaded region in first quadrant only. Okay, now first quadrant area will find. This area is nothing but simply upper curve area minus lower curve area. Upper curve area minus lower curve area. Now point of intersection is 0, 0 to 1, 1. Okay, so x limit 0 to 1. What is upper curve here? Y is equal to x is upper curve. What is lower curve here? Y is equal to x square is lower curve. Okay, y2 minus y1 dx. y2 is upper curve, that is x, minus y1 is lower curve, that is y is equal to x square. So what will get 2 times of integral 0 to 1 y2 minus y1 dx is nothing but 2 times of integral 0 to 1 x minus x square dx. Okay, so here 2 times of, now x minus x square, x integration is x square by 2 minus x square integration is x cube by 3, lower limit 0, upper limit 1. So if you substitute upper limit, anyhow lower limit is 0 only, no? If you substitute upper limit, so 2 into 1 by 2 minus 1 by 3, 2 into LCM is how much? 6, 3 minus 2. Okay, 2 cancel. So what is the final answer? 1 by 3 square units. Okay, next question. My next question, question number 7, find the area of smaller part of the circle x square plus y square is equal to a square, cut off by the line x is equal to a upon root 2. Okay, the question is to find area of the smaller part of the circle x square plus y square is equal to a square, cut off by the line x is equal to a upon root 2. Okay, what are the curves given here? First of all, given circle x square plus y square is equal to a square. Now this is a circle whose center is origin, radius is a units. So we will intersect x axis at a comma 0 minus a comma 0, y axis at 0 comma a, 0 comma minus a, center is 0 0. Okay, and what is the line given? Line is x upon, x is equal to a upon square root of 2, x is equal to a upon square root of 2. Now this is the line x is equal to a upon square root of 2. Now smaller part of the circle, now this is a bigger part and this is smaller part. So smaller part means this area we have to find. What area? P, A, Q, M, P. Okay, this area. First of all, where this line and circle intersect each other. Okay, point of intersection of line and circle. Now what is the line? X is equal to a upon root 2 and circle is x square plus y square is equal to a square. Now solving these two, I will solve into, in place of x we will write a upon root 2. So a upon root 2 whole square plus y square is equal to a square. So this is how much? A square by 2 plus y square is equal to a square. Now if you write this term this side, y square is equal to a square minus a square by 2. Y square is equal to a square minus a square by 2. If you take LCM, LCM is what? 2. So 2a square minus a square by 2. Y square is equal to a square by 2. So y is equal to plus or minus a upon square root of 2. Okay. So y is equal to plus or minus a upon square root of 2 means x is equal to a by root 2 and y is equal to a by root 2. That is one point of intersection. Another point of intersection is x is equal to a by root 2 and minus a by root 2. Okay, so point of intersection of circle and line is point P, a upon root 2 comma a upon root 2, and point Q, a upon root 2 comma minus a upon square root of 2. Okay, P is in first quadrant, Q is in fourth quadrant. Okay, now the point of intersection of circle and line in first quadrant is what? In first quadrant is a upon root 2 comma a upon root 2. Okay, a upon root 2 comma a upon root 2. Now this area, shaded region area, what it is? Area, required area PAQMP. Okay, what is M is point of intersection of line x equal to a upon root 2 on x axis. What it is? A upon root 2 comma 0. Okay. Now this area, instead of calculating this entire area, simply you calculate shaded region area in first quadrant and multiply with 2. Okay, area of shaded region in first quadrant only. Okay, 2 times of that quantity. So required area PAQMP, this is equal to 2 times of area of shaded region in first quadrant only. First quadrant only means area under PAMP. Okay, 2 times of area under PAMP. Okay, now 2 times of what is lower limit here and upper limit here? X value a upon root 2 to a. So lower limit is a upon root 2, upper limit is a. Okay, so lower limit is a upon root 2, upper limit is a. Okay, modulus of y dx, because anyhow we are considering first quadrant, y is positive. So y is equal to what we can write here? From circle, y square is equal to a square minus x square, y is equal to plus or minus square root of a square minus x square, because we are considering in first quadrant y is positive, that is y is equal to square root of a square minus x square. So area is equal to 2 times of integral a upon root 2 to a square root of a square minus x square dx. Now we have direct integration formula for integral square root of a square minus x square dx. What is the formula? X by 2 into square root of a square minus x square plus a square by 2 into sin inverse of x by a. Lower limit is a upon root 2, upper limit is a. Okay, now substitute upper limit minus lower limit, that is substitute a in place of x, variable x. So if we substitute a in place of x, what we get? A upon 2 into square root of a square minus a square, okay, plus a square by 2 into sin inverse of a by a, that is substitution of upper limit, minus lower limit substitution. Lower limit in place of x, if we substitute a upon root 2, what will get? A upon root 2 by 2 into square root of a square minus a upon root 2 whole square plus a square by 2 into sin inverse of a upon root 2 upon a. Okay, now here a square minus a square is 0, so this part is 0, plus a square by 2 sin inverse of a by a, sin inverse of 1. Okay, minus in case of lower limit, what we get? A by root 2 by 2, nothing but a upon 2 root 2, a upon 2 root 2 into square root of a square minus a square by 2, a square minus a by root 2 whole square is what? A square by 2. Okay, plus a square by 2 into sin inverse of a by root 2 upon a cancel, sin inverse of 1 upon root 2, sin inverse of 1 upon root 2, 1 upon root 2. So here 2 into, this value is how much? 0. Okay, a square by 2 into sin inverse of 1. Here by substituting upper limit, we have 2 into a by 2 square root of a square minus a square plus a square by 2 into sin inverse of a by a, minus substitute lower limit in place of x, that is a upon root 2. If we substitute in place of x, what we have? A upon root 2 upon 2 into square root of a square minus a by root 2 whole square plus a square by 2 into sin inverse of a by root 2 by a. Here a get cancelled. So here a is equal to 2 times of a by 2 into a square minus a square 0, so this term is 0, plus a square by 2 into sin inverse of a by is how much? 1, sin inverse of 1 minus a by 2 root 2 into square root of a square minus a square by 2, a square minus a square by 2 plus a square by 2 into sin inverse of 1 upon root 2, because a get cancelled. No? Now here sin inverse of 1 is how much? Pi by 2. So a square by 2 into pi by 2 minus here a by 2 root 2. But this is how much? Square root of, if you take LCM, 2a square minus a square by 2, okay, under root a square by 2 plus a square by 2 into sin inverse of 1 upon root 2 is pi by 4, okay. So this is pi a square by 4 minus here a, root of a square is a into a square upon 2 root 2 into root 2, 4 minus pi a square by 8. Now if you observe, in each term we have a square by 4, a square by 4, a square by 4. So a square by 4 I will write outside. So a square by 4 into 2, a square by 2 into, here pi a square by 4, no, a square by 4 came outside, means pi minus pi a square by 8, a square by 4 already came outside, we have pi by 2. So pi minus pi by 2 is how much? Pi by 2 minus a square by 4 already came out, no? So pi by 2 minus 1. So what is the final answer? A square by 2 into pi by 2 minus 1 square units. Okay. But here question is to find area of the smaller part of the circle x square plus y square is equal to x a square, cut off by the line x is equal to a by root 2. Now, first of all, we will find point of intersection of circle and line. Okay. So by substituting in place of x a by root 2, okay, what we got? Y is equal to plus or minus a by root 2. So what are the point of intersection? A upon root 2 comma a upon root 2. In fourth quadrant, a upon root 2 comma minus a upon root 2. Okay, first quadrant point of intersection is what? A upon root 2 comma a upon root 2. If you drop a perpendicular on x axis, what is that point? M is a upon root 2 comma 0. Okay, so this shaded region area, okay, required area PAQMP, this area is equal to 2 times of area of shaded region in first quadrant, that is 2 times of area of PAMP. Okay, so here PAMP, now x moves from a by root 2 to a, so lower limit is a by root 2, upper limit is a. Now what is this? Is area under the circle, no? Area under the circle. So y is equal to how much? Y is equal to square root of a square minus x square. So area is equal to 2 times of integral a upon root 2 to a square root of a square minus x square dx. Okay. Now direct integration formula, we have integral of square root of a square minus x square is x by 2 into square root of a square minus x square plus a square by 2 into sin inverse of x by a. Lower limit as a upon root 2, upper limit as a. So in place of x if we substitute a, so a by 2 square root of a square minus a square plus a square by 2 into sin inverse of a by a. Okay, substituting upper limit minus substituting lower limit, in place of x substitute a upon root 2, so a upon root 2 by 2, okay, into square root of a square minus a upon root 2 whole square plus a square by 2 into sin inverse of a upon root 2 upon a. So here this part is 0 because a square minus a square is 0, so this is 0, a square by 2 into sin inverse of 1. This is upper limit minus lower limit part a by 2 root 2 into square root of a square minus a square by 2. So nothing but a square by 2 under root, okay, plus a square by 2 into sin inverse of a get cancelled with sin inverse of 1 upon root 2, a square by 2 into sin inverse of 1 upon root 2. Okay, now if you substitute the values, a is equal to 2 into a square by 2 into sin inverse of 1 is how much? Pi by 2 minus a by 2 root 2 into square root of a square by 2 plus a square by 2 into sin inverse of 1 by root 2 is pi by 4. Okay, so this is how much? Pi a square by 4 minus a root of a square is a into a square upon 2 root 2 into root 2, nothing but 2 root 2 into root 2 is 4 minus pi a square by 8. My a square by 4 if you write outside, because here we have a square by 4, a square by 4, a square by 4, a square by 4 if you write outside, 2 times of a square by 4 is a square by 2, here a square by 4 common means pi, here a square by 4 common means pi by 2, pi minus pi by 2 is pi by 2 minus 1 square units. Okay, I will conclude up to here, remaining problems we will discuss in next class.